moment, let's forget programming, computers, 0, 1, etc. Suppose you are that dreadful monitor of the class and you need to arrange a set of students in the non-decreasing order of their height. Non-decreasing is the perfect word to use here because if two students have the same height and you put them together, they are not in the ascending order but certainly non-decreasing. So there are n number of ways to solve this problem, but
I'll give you one feasible solution. Here it goes. Start with the first student, compare him with the second, and if the height of first student is more than second, exchange them, otherwise leave them as they are. Now compare second and third student, and if the height of second student is greater than that of third, exchange them, otherwise leave them as they are. Repeat this process till you compare the second last student with the last one. So what do you get in the end? Let's see.
So now we'll see how to sort 5 elements in an array using the procedure what we already discussed. So here, as you can see, there are 5 elements in an array. The positions are 0, 1, 2, 3, 4 and the elements are 8, 6, 4, 9, 2. You can consider this 8, 6, 4, 9, 2 as the height of 5 students. According to our algorithm, we are supposed to compare 8 and 6, that's the height of first student with the height of the second student, as we said. So by comparing 8 and 6, you can see that 8 is greater than 6, so we need to swap. Let's swap. 6, 8, 4, 9, 2. Next, we'll be comparing 8 and 4. So by comparing 8 and 4, we can see that 8 is greater than 4. Again, swap. 6, 4, 8, 9, 2. Next, we are comparing 8 and 9. 8 is smaller than 9, no swapping. 6, 4, 8, 9, 2. Now we'll compare 9 with 2, and as 9 is greater than 2, we need to swap. 6, 4, 8, 2, 9. This is the end of stage 1 of our procedure. By the end of this, you can see that the 9 or the last position has the value which it should actually contain. 9 has reached the position it should be and we need not touch it anymore. So we'll be applying the same algorithm from position number 0 to 3. So it will be like 6, 4, 8, 2, what we have right now here, as you can see. And we'll apply the same algorithm. So we'll compare 6 and 4. By comparing, we can just swap it as 6 is greater than 4. So 4, 6, 8, 2, 9. Moving on next, comparing 6 and 8. No swapping required, so we can just copy it down. Next, we're comparing 8 and 2. We need to swap. 4, 6, 2, 8, 9. By the end of this, you can see that 8 is also at the position that it should be. So we can now skip 3 and 4th position, 3rd and the 4th position here. And we need to do the same, apply the same algorithm from position number 0 to position number 2. Moving on ahead, we'll compare 4 and 6, no swapping required. 4, 6, 2, 8, 9. We'll compare 6 and 2, swapping required. So 4, 2, 6, 8, 9. This is the end of our 3rd stage. We just have now 2 elements in our not sorted order, that's 0 and 1, position number 0 and 1. So now we need to check them. So if we compare 4 and 2, 4 is greater than 2, we need to swap it. So it's like 2, 4, 6, 8, 9. End of bubble sort algorithm. What we have here is a sorted array, what we actually require, and this is how a bubble sort algorithm works.
Here is the algorithm for bubble sort ready to be implemented in any of the programming languages. It belongs to complexity class O of n square. It accepts 2 inputs. One is the array with position 0 to n minus 1 and another one is n as the size of this particular array. As you can see, it has 2 loops. One is the I loop and another one is the j loop. Notice that j loop runs from 0 to n minus 1 minus I, so that each time while comparing we leave one element from the end. So that's all about bubble sort. You can find the link in the description below for the algorithm and for its implementation in various languages. Thanks for watching.